So the topic is endogeneity. Actually, let me mention some of the incident which I came across with endogeneity. In almost every paper, when you send for the publication, this is one of the common question that how you explain the endogeneity in your model. Very common question. So how you incorporate or how you describe the endogeneity in your model. And one of my friend who sent the paper, his paper was based on smart PLS, and even he got the same suggestion from the reviewer that how you incorporate endogeneity in your model. So actually this term is so common that we need to explain and address the problem of endogeneity. So first of all, we should know what is the endogeneity problem. We should explain that. So for that I have this slide. Okay, now very basic. The y here is dependent variable, x is independent variable, and we are trying to explain the y with the help of x. Simple. And in this model, this is a simple regression model, and this model assumes that if this model is complete, the error term should be as minimum as possible. The error term should be as low as possible. And there are, that there is the assumption of ordinary least square method, according to which we assume that this error should be uncorrelated with dependent variable and also with the independent variable. There should not be any correlation with error term and the dependent variable and independent variable. But the problem is that due to many reasons, due to many possibilities, this error term is found to have correlation with dependent variable. The error term is found to have the correlation with dependent variable. Now, what is the reason of that? When it is possible, and what is the reason of this problem? So one of the problem is that the problem is of omitted variables. If you are not including some important variable which can explain the y, which can explain the dependent variable, then the effect of this omitted variable comes into the error term. And as a result, this error term is found to be correlated with dependent variable y. So one of the reason is that omitted variable, some important variable which can explain by y, but is not the part of the model. That problem is known as omitted variable problem. Second is that sometimes there are many variables which we cannot measure, like qualitative variables we cannot measure, like mood of the market, mood of the customer, and the sentiment of the industry. There are many variables which we cannot measure, and we don't know about these variables, and we cannot also measure these variables, and because of that there is a endogeneity problem comes. Endogeneity means the correlation between the error term and the dependent variable exists. So if the correlation between error term and the dependent variable exists, this is simply endogeneity problem. And one of the problem is omitted variables. Second problem I said is the measurement, when you don't have any way to measure some of the variables which can influences y. The third concept is called reverse causality. Reverse causality means there is one independent variable And the concept of reverse causality, like y is influencing the x is influencing the y is influencing the x is influencing the y. This is called reverse causality. Like FDI is having impact on GDP, FDI is having impact on GDP, and because of the increasing GDP, FDI also comes next year. So both are causing each other. FDI is helping in improving the GDP, and increase in GDP will attract the FDI. So this concept is called reverse causality. So reverse causality we explain like this: X is causing Y, and Y is causing X. So I hope you now understand when this error term should be correlated to the dependent variable. So there are three possibilities. If you are not taking any important variable, that is called omitted variable, and you are having problem in measuring the independent variable, and third, you are having the possibility of reverse causality, and because of that you have a problem. The problem is known as endogeneity problem. Now, in most of the research, we want to explain the dependent variable. The purpose is to explain the dependent variable. So one simple question comes, have you incorporated all the variables in the model which can explain the y? Right. So endogeneity issues simply means, have you incorporated all the important models which can influence the dependent variable or not? Right. So it is almost impossible because sometimes the variables is not mentioned in the literature review. It means you don't aware about that. Right. So for example, if I ask you, what are the different factors which can influence the happiness? Right. What are the different factors which can influence the happiness of the person? You can incorporate some of the variables like income, health, and some other relationship, like, but you cannot incorporate all the variables I'm telling you, because some variables you don't know, some variables you cannot measure, and maybe because of that, because of the specification error, it means your model is incomplete. You may have the endogeneity problem. Now the question is that how to incorporate or how to solve this kind of problem, how to solve endogeneity problem, right? So in the literature, there is one very simple way that answer is known as instrument variables. So now I'm showing you the concept of instrument variables. Instrument variables are those variables which you can say is the proxy of the variables which cannot be incorporated in the model, right? So, and one of the problem of endogeneity is simultaneous problem. X is causing Y, Y is causing Z, Z is causing A. So this kind of problem is also known as the endogeneity problem. So these kind of problems. So I'm explaining you, listen carefully. Suppose in the regression model, one of the independent variable is also having correlation with the error term, right? So like you can say here, the X is causing Y, and the error term is also having correlation with Y dependent variable, but the error term is also related to the independent variable. So this problem will create a problem in the regression model and will create the biasness of the slope coefficient, right? So here you can see that because the error term is also found to be correlated with one only dependent variable. So in this case, we can say this X is also showing the endogeneity. So this is not exogenous. because X variable is also correlated with the error term. So can we say this X is purely exogenous? In that case, we cannot say the X is purely endogenous and we have to resolve this problem. So because of this problem, endogeneity also comes. This kind of problem is solved by a method called second stage least square. So now I am telling you two solutions which we use in the setup. The most common instrument variable estimator is second stage least square, and second method we are having the GMM method to solve the problem of instrument variables. So in problem we are having two solutions of endogeneity problem. One is called second stage least square, and second problem is known as GMM method for solving the problem of endogeneity with the help of instrument variables. Okay, so I hope now I'm going to start the problem with the help of instrument variables. So tomorrow I will discuss on the GMM. So GMM I will not discuss today. Today I am going to discuss the second stage least square method of solving the problem of endogeneity in regression model. So let's try to understand the concept of endogeneity, which can be solved with the help of second stage least square method. So in this case, you can see that normally we have this kind of equation that y is equal to alpha plus beta 1 x1 beta 2 x y2. So I am giving this name y2 y because it is found that this variable is having some relationship with the error term. So when one of the independent variable is found to have correlation with the error term, so in this case what will happen, your slope coefficient beta 2, this is my beta 2, this will be biased beta. So this will be biased beta, right? Why? Because ideally, according to the assumption, the error term should not be correlated with any of the independent variable. Why? Because these two variables are independent or exogenous. So we assume that these variables are exogenous. These variables are exogenous. So error term should not be correlated with any of the independent variable. But what will happen when the error term is found to be correlated with the any one of the independent variable? So because of this correlation, right? Because of this correlation, the coefficient of the independent variable is biased, and we have to find out the solution of that. So there is the problem is coming for because of two reasons. This problem that beta 2 is biased is coming because of two problems. Either the error term is having correlation with the independent variable, or it may be possible that y1 is the dependent variable, y1 and y2 are having the problem of reverse causality, means y1 is affecting y2 and y2 is affecting y1. So both the problems can be solved by the method known as second stage least square method. Okay, now if you are getting the concept, please type yes, and otherwise I will move forward. Okay, so now let me repeat something, that what is endogeneity? Endogeneity means when the dependent variable is found to be correlated with the error term, and you have three problems in the model. Like I told you, when dependent variable is found to be correlated with the error term, this is the case one of endogeneity, and it is possible because of three reasons, right? And the the endogeneity can be solved with the help of two methods: second stage least square and the GMM method. GMM method I will discuss tomorrow. So today I am discussing the problem of endogeneity which can be solved with the help of second stage least square. Now, in second stage least square, what is the reason of endogeneity and how can we solve that? We are going to discuss it. So in this regression model, I am saying that the y1 is found to be correlated with u, error term, and one of the independent variable is also found to be correlated with the error term, and because of this, the beta 2 is found to be biased. This biased beta 2 is indicating the problem of endogeneity, and we are going to solve this problem with the help of second stage least square. And this problem is coming because of two reasons: that error term is found to be correlated with one of the independent variable. So this variable is not actually purely exogenous, it is endogenous variable. And this endogenous variable is having reverse causality with the dependent variable y1. Right? Okay. So now what is the concept of instrument variable in second stage least square that I am going to show you? So we have to solve this problem with the help of some instrument variables. Now, what is the instrument variables? Okay. We want that the covariance. Okay. Actually, in this slide, I should put this not equal to. It is given that that y2, which is one of the independent variable, is having correlation with the error term. So if you remember, I told you that this error term is having found to be correlated with the y2. Suppose it is given that the y2 is correlated with the error term, y2 is correlated with the error term, and because of this correlation, the endogeneity is there in the model. So how to solve it? So this can be solved with the help of some instrument variable. So here I am assuming that there is one independent variable we have in the data, which can be assumed to the instrument variable, right? And in another words, I am telling you one thing. This z variable is having one property, that number one is z and y2 and y1. So y2 is actually the complete mediating variable between the z and y1. This is one of the condition for z to act as an instrument variable, right? I repeat, one of the condition that z can be applied as a instrument variable, that z if will affect y2, y2 will affect y1, but z will not affect y1. So you have to find out those variables. You have to find out those variables which can influence the y2, but which cannot influence the y1. It means y2 is purely mediating variable between the z and y1. Okay, so this property I mentioned here, condition number 3. The other property of this instrument variable is there should not be any correlation with the error term and the z. So the correlation between the instrument variable and the error term should be 0, right? Second, the correlation between the error term z variable and y2 variable is not equal to 0. Actually, I have to find out this this symbol of not equal to. So in hurry, I just put equal to everywhere. So I am correcting here. The covariance between the instrumental variable and the second y2 should not be equal to 0, but the covariance between z and the error term should be equal to 0, and the rate of change of y1 with respect to the instrument variable, right, uh, should also be 0. Yeah, actually, so this should be 0. Let me try to, okay. Actually, this is wrong. This is 0. I will send you the correct slide. Don't worry, because there are some typing mistakes in this slide. So I repeat once again, the correlation between Z and the error term should be 0, right? The covariance of Z with Y2 should not be 0, and the impact of Z on Y1 should be 0. So this is the property of the instrument variables that we can incorporate in the model. Right, so I will send you the correct slides, so don't worry on that. After that, after knowing the property of the Z, now the structure is like that. In second stage least square, the structure is like that. This is the error term, and the error term is having impact on the Y1, which is the endogenous variable, and YT variable is also found to have the correlation between error term, so showing the endogeneity problem. And because of this error term correlation, the beta is found to be biased. This beta is found to be biased, and X is a purely exogenous variable. There may be many exogenous variable in the model which are having significant influence on Y. So now, because Y2 is having significant effect or significant correlation with error term, so to control this correlation, we introduce a new variable Z, which is nothing, which is a instrument variable. And now this is the structure of the model. So this is the structure of the model now, where Y2 is complete mediating variable between the Z and Y. And this model can be run in 2 steps, right? And that's why, because of this 2 steps modeling, this model is known as second stage least square. Okay, so before going to the second stage least square, I'm going to show you one thing which I hope explains the concept very well. Now in this case, you can see that suppose this is my dependent variable y1, this is my independent variable, but actually that is endogenous y2, and this is my z, so all these is the cross section or intersection between all the three variables, right? So y1 is my purely endogenous, y2 is my independent but endogenous. Endogenous means correlated, having significant correlation with the error term, and this is my instrument variable. Now see clearly, you have to think again and again what I am going to explain. So I represent this B, C, D, F. So what they represent, B, C, D, F, what they represent? So number one, the correlation between Y1 and Y2. This is Y1 and this is Y2. The intersection part is like this, right? So this portion, this proportion of the variance of Y1 explained by the Y2, or we can simply say the beta in the regression model is explaining this part, and this part is coming from three portions, B plus C plus D, right? So I hope there is no problem in this. We are just saying that the y1 having the y1 is influenced by y2, and this influence is represented by the area B, C, and D. Right now, you may be thinking that why I am dividing B and C, because this whole is explained by y2, right? So you may be thinking like this: why I am dividing this C into B plus C? So I just want to show you that this is the endogeneity bias. This B is representing what? Endogeneity bias. Endogeneity bias. Endogeneity bias means this B is actually the correlation between Y2 and the error term. So I represent here. What is this B? This B is the correlation between the Y2 and the error term, right? So when you run the model, this is the biasness which is incorporated in the model. So we want to improve, we want to find out the solution of this beta, which is a biased beta, right? This B is representing the biasness because of endogeneity. Okay, and this endogeneity is coming from the error term. Okay, what is the OLS error? This OLS error is actually the portion A. This is the portion A, which is not explained by the Y2. This portion is not explained by the Y2 plus some B, and this is the error term, that variance of the error term which is having the correlation between the Y2. So because of this biasness, now we are incorporating the dummy variable Z. So not dummy variable, sorry, instrumental variable Z. So what this instrumental variable Z? So this instrumental variable Z will correct the biasness because of endogeneity by the D, right? So by the D. So here this OLS, which is using B plus C plus D to estimate Y, having bias slope coefficient here to be, which is replaced by instrumental variables use D only variation in Y2, not correlated with the error term, right? So this portion is actually that proportion of the Y2 which is not correlated with the error term. So this variance will replace the endogeneity biasness in the model, right? So this is the insight which I want to give you to explain the removal of endogeneity bias by the instrumental variables. Instrument variables. Actually, mathematically it is quite complicated, so I just try to explain with the help of this Venn diagram. Now, what happens after applying the second stage least square? Just see, if you apply the OLS coefficient, the beta is equal to the covariance between Y1 and Y2 upon variance of the Y2. This is the mathematical formula for calculating the slope coefficient in OLS. But here we know that this coefficient is a biased coefficient because of the endogeneity. So we go for second stage least square. The second stage least square will apply the formula beta is equal to covariance between Z and Y1 upon covariance between Z and Y2. So the coefficient calculation will change in the second stage least square, and this coefficient is free from the endogenous biasness and is a solution of the endogeneity problem in the regression model. So let's explaining the concept of second stage least square now. Now, what happens after including the Z? The variation in Z, the variation in Z replaces a part of the variation of the endogeneity variable Y2, right? So this variation is replacing that variation which is caused by the error term in the model. Now, what actually we do in the second stage least square? So just try to find out, just try to see the relationship. We are given this relationship. This regression model is given. We want to apply that, where y1 depends upon the x1, which is my one of the independent variable. Y2 is found to have correlation with the error term, so I put is y2 not x2 to represent this variable is creating a problem of endogeneity biasness in the regression model, and because of that the correlation between y2 and the error term is not equal to 0. So this covariance or correlation between y2 and the error term is not equal to 0. This problem is known as endogeneity biasness. And how to remove with the second stage least square? The method is this. So what is the method? I said that it is a two-step method. In step number one, we apply the regression model like y2. Y2 is my endogenous variable, and I am applying this regression model on Z and X. Z and X. On the basis of my first equation, I will predict the value of y2. So I will predict the value of y2, and these predicted value, let's say, are known as y hat 2. So this is the predicted values of the y from the second equation. So I put this predicted value in the second equation, where y1 is my dependent variable, beta and x1, and y2 predicted is my independent variable. So if I run this model, the endogeneity biasness will vanish, and this is the solution of endogeneity biasness in the regression model. And these are the commands which we will use for removing the endogeneity biasness from the data. So now I am showing you the process how to solve the endogeneity problem in Stata.